Hi there, Mr. Sutton here, bringing you the Pre-Cal Honors 7-1 Extra Practice Number 1 solutions on graphing conic sections. For this one, we have a circle to graph. So we've got a center of 4, comma, -1, and then the radius is going to be the square root of this number over here. So square root of 16 is 4. So let's graph our center, and let's see here. Just judging by where that center is and what the radius is, I'm going to need to make my grid lines go by 2's. So center is going to be 4, comma, -1 right there. And I'm going 4 in every direction. So we'll go 4 up, 4 to the right, 4 down, and 4 to the left. And then connect the dots, and there's our circle. On this problem, I've got something in x squared plus y squared format. So this is going to definitely be a circle. We have a center of 0, because this is really x minus 0, so 0. And then -3 is the y value. For my radius, I have the square root of the number over here, square root of 9, which is 3. And just judging by where the center is and how much the radius is, these grid lines are going to have to go by 2's to fit everything on here. So we have a center of 0, comma, -3. And then we're going 3 in every direction. So 3 up, 3 to the right, 3 down, 3 left, and connect the dots to get our circle. On this problem, we've got a semicircle whenever you have the y or x equals the square root of something else squared. So we're going to first put this in something that looks like a circle form, and then we'll use that to just graph half of the circle. So I'm going to start by squaring both sides to get rid of this square root. And actually, I've got to do that now. Yep, so I've got y minus 3 squared. And then I've got 4 minus x squared over here. Now let me just add x squared to the other side. And at this point, I've got something that looks kind of like a circle form. So I've got a center of 0, comma, 3. Radius of square root of 4 is 2. And now I've got y equals a positive square root in the original equation. So y tells me it's going to be a top or bottom half circle. The positive tells me I want the top half of the circle. So graphing all this, we've got a center of 0, comma, 3. And then I'm doing the top half of the circle, so I'm going to go the radius in every direction that would give me the top half. So that's going to be 2 to the left, 2 up, 2 to the right, and then graph our semicircle. For this problem, I've got some fractions, some squareds, I've got a plus, I've got an equals 1. This is all pointing to this being an ellipse. So let me get my center. That's going to be 2, comma, 0. And then I need the x radius and the y radius. The x radius is going to be the square root of the number under the x squared, so square root of 4 gives us 2. And then for the y radius, we have the square root of 49, which is going to give us 7. So graphing out my center, and I'm going to need to go by 2's on this one, because if I'm going 7 in each direction, definitely not going to be able to fit all that on this grid line. So going by 2's, we've got the center of 2, comma, 0 right there. My x radius says go 2 left and 2 right. So here's 2 left, here's 2 right. And by the y radius, I have to go 7 up and 7 down, and then connect those to get my ellipse. On this problem, it looks like I'm trying to graph an ellipse based on the plus here and the equals 1. So I've got my center of 2, comma, -1. And then the x radius, square root of the number under the x's, it's going to be square root of 16, or 4. For the y radius, I've got square root of 36, which is 6. And I'm going to need to go by 2's for these grid lines, just based on how far I'm going in each direction. So let me graph my center, 2, comma, -1. That's going to be down here. And then my x radius is taking me 4 to the left, 4 to the right. My y radius is taking me 6 up and 6 down. And then connecting all of those is going to give me my ellipse. For this problem, we've got an ellipse we're trying to graph. We have a plus here and a 1 here, so that's an ellipse. So I've got a center of 2, comma, -4. An x radius of square root of 9 here under the x's, that's going to give me 3. And the y radius is a little tricky, but you can pretend there's an invisible denominator here of 1. So square root of that is going to give us 1. And now let me do my graph. So let's see, if I'm at 2 comma negative 4, let's see, I think I can fit all that without making a scale of 2. So let's do it. 2 comma negative 4, and then we're going left 3 and right 3 based on the x radius, and then we're going up 1 and down 1 because of the y radius. So there's the ellipse. On this problem, it looks like we have a hyperbola based on the minus and the 1 here. So let me get my center first. That's going to be 0 comma 0. And then for the x radius, that's under the x squared. Square root of 16 gives me 4. For the y radius, that's the square root of 4 under the y squared. So that's going to give me 2. And now we have a center of 0, 0. Let me go 4 to the left, 4 to the right. X radius is 4. And then we're going 2 up, 2 down. Now with a hyperbola, we draw a box using those points as the midpoints. And then for the asymptotes of the hyperbola, we draw those through the corners of our box. So there's one, there's another one. And now we have to figure out, is this an up-down or a left-right hyperbola? So based on the fact that the y squared is positive, the positive fraction, that means this is going to be an up-down hyperbola. So we have a branch up here and another branch that's going to be down here, following the asymptotes going through those points. For this problem, we have a hyperbola we're trying to graph based on the minus and the 1 there. So our center is going to be negative 1 comma negative 1. And we're going to have an x radius of whatever the square root is of this stuff under the x, so that's going to be square root of 16 or 4. Y radius is square root of this 16 right here, which is also, of course, 4. And then I have to graph my center and make my box based off of these left, right, and up, down radii. So we have the center negative 1, negative 1. And I'm going to go ahead and actually make my grid lines go by 2s here, because otherwise I'm not really going to be able to fit everything and get a good picture of this hyperbola. So now let me go 4 to the left, 4 to the right, 4 up, 4 down. Draw a box with those as the endpoints. Draw the asymptotes through the corners of that box. And here's the other asymptote going this way. And now since my x squared is the positive fraction, that means that I have a left-right hyperbola. So I'm drawing a hyperbola over here on the left and another one over here on the right. For this problem, we have a hyperbola to graph because we have a minus here, some squared functions, and a 1 over here. So let me get my center first. That's going to be 0 comma negative 2. Careful, the y is listed first here, but it's still a y value. And then let me get my left-right radius. That's going to be the square root of whatever's under the x squared, so that's 2 in this case. Square root of 4 is 2. And then the up-down radius, we have the square root of an invisible 1, which is 1. So let's see, if I do a center of 0, negative 2, and I go 2 in each direction, yeah, I should be able to fit all that on a graph without making these go by 2s. So we got 0 comma 2, negative 2, and we're going left 2, right 2, left 2, and then we've got up 1 and down 1. Draw a box with those as the endpoints. Draw the asymptotes through the corners of that box. Now I notice that I've got y squared is the positive squared term here, so that means we have an up-down hyperbola. So we have one up here above, and then we have one down here below, and those are our two branches.